Hello and welcome back to another episode of the Natural Number Game with Lean 4. Today we'll be tackling the boss final level of the Advanced Multiplication world, Mole Left Cancel, which apparently people find very hard. And it says that many of the levels in this game can be solved by running at it, do induction on one of the variables, keep your head, and you're done. And it says if we like a challenge, we can stop reading at the end of this paragraph and try solving the level now by induction and seeing the trouble we run into and then reading the rest of the comments afterwards. This level has a sting in the tail, and if I'm a competent mathematician, I can try to figure out what is going on. And then it also recommends writing a math proof of the theorem in this level. What statement do you want to prove with induction? And it's subtle. So I won't read the hints, and I'll try to bash away at the theorem. We'll see where we get, and then I'll read the hints and see if I do get stuck. Theorem, mole, left, cancel. The one hint that we did get from the introduction of this is induction. I also have I'll move this line. H, A, which is A not equal to 0. I want to prove A times B. I don't need parentheses here. A times B equals A times C implies B equals C. Okay, so this is like the left cancel, but for multiplication. Okay, all intro quality, and I guess we can also maybe look at what we did for the left cancel in the addition world. How do we do add left cancel? Okay, we did induction on T. Okay, so thing being added after introing H. Well, let's merrily try that as well. So induction on A. Induction A with, induction A, 0, sorry, is it like this? With, yeah, okay. Successor, A prime, inductive hypothesis, sorry. Hopefully one of these legs is easy. This 0 times B equals 0 times C. 0 doesn't equal 0. Okay, well, HA is ridiculous, so we could do HA dot exact HA dot elim or HA dot irreflexive dot elim. Okay, so that takes care of our 0 case. So here I'm just, instead of doing false dot elim of this, I'm just doing dot elim, and then we saw irreflexive earlier in the last video, or the second to last video. Let's think here. What's going on? We have our inductive hypothesis. A does not equal 0 implies, or A prime does not equal 0 implies A prime times B equals A prime times C implies B equals C, and our goal is B equals C. So we need to somehow get A prime does not equal 0, and we have HA, which is successor of A prime doesn't equal 0. And we have EQ, which is successor of A prime times B equals successor of A prime times C. Ooh. Okay, well, I can see where the tricky thing is, because in our inductive hypothesis, we have this A prime does not equal 0, Do we know that A prime doesn't equal 0? I don't even know. Why would A prime does not... No, there's nothing that tells us that A prime doesn't equal 0. All we have is our HA, which is A doesn't equal 0, or successor A prime doesn't equal 0. I don't think we have any way of proving A prime could totally be 0 here. Because if A is 1, then A prime is 0. Ooh. Does this work? Successor of successor. Can we break it up like this? I didn't think so. I'm use alternative. Oh, can we go like this? Is this actually valid? Don't have like the 0, the 1, and the like bigger case. No, they can do that. I don't think I can solve this then. I guess I'll turn to pencil and paper, try to work this out mathematically. I think this a bunch mathematically, and then come back. Alright, be right back. Okay, I haven't quite solved it, but one thing that I found kind of interesting was when I did induction B with all of this. This is just the scaffold for induction B, and I look here, we have our equality, we have, okay, B prime, we have our inductive hypothesis, and we have our EQ, which is like our original hypothesis. I guess I could call that H. Maybe I should call that H for clarity. But here, the interesting thing is, inductive hypothesis A times B prime equals A times C. This is A times successor of B prime equals A times C. Maybe we get a contradiction or something? I'm not too sure, but let me play around with this. That's easy, but let me do this first. Maybe I can like rewrite backwards H at IH. Can I do that? A times, yeah, that looks promising. Now we have inductive hypothesis A times B prime equals A times successor B prime implies that, and we know false implies anything. So maybe we can get like, is this progress? I don't even know. I guess false implies everything, but if we get false implies B prime equals C, we get B prime equals C, then we get B prime equals B prime. Okay, I think that I think this angle of attack could work. Let's think. Can I do like intro H prime at H? No. Rewrite mole successor. I guess I could put that here. Mole successor. 1L. Okay. Now we have a times b prime equals a plus a times b prime. And a is not equal to 0. Interesting. Is there some like successor not equal to successor or something else? Advanced Edition World. Successor, or no, not equal successor to self. Okay. That's promising. I think I can massage this into get some sort of contradiction. And then we'll be good. Oh, okay, I see. We can get this to be 0 plus that. Add 0. Or 0 add maybe. Can I do a times b prime like this? Okay. Associative. Add 0. Okay. Add left cancel. Oops, right cancel. Why did that not work? Oh, I need to specify the things. 1, 2, 3, 4. Okay. Add right cancel. ATB. Okay, so our A is 0. Oh, okay. That worked. What is IH now? Oh, no, that didn't quite work. 0. T is okay, let's do B first. B is A. Oh, we don't want to like apply it to H. Let F equals H. IH. Is that not how you do this? Oh, because it's implication. Can I really not get that part out of it? IH dot let F prime equal IH dot IH dot. I can't get anything out of it. IH, really? What about H dot? H got a ton of things. But IH has a lot of things. It doesn't have a lot of things. Okay. plus b prime. Okay, what is f? F implies this, 0 equals a. So if f finds that, we get 0 equals a. Can I really not do rewrite f at IH? Well, I can, but then I get into some weird situations. Which I don't think I want. Do I? IH, A plus A plus. Because successor case, what is this? Successor. Sorry. 0. Sorry. A double prime. With no, this is not look promising. I'll use alternative 0. Sorry. I use alternative. Okay, what can we do here? Okay, so if 0 plus a plus b equals a plus a plus b implies b prime equals c. Yeah, I'll officially say that I'm stuck here, so I will read the hints that they have for this level. Okay. Yeah, I tried induction on C initially. Then your inductive hypothesis, PC is A times B equals AC implies B equals C. So for your inductive step, you're able to assume this, AB equals AD implies B equals D. And your goal will be to show A times B equals A times D plus 1. Our inductive hypothesis is useful. Let's see if this is true. When we do induction on C, or I guess the same as doing induction on B, our inductive hypothesis is useless because it's not true. Yeah. So induction on, if we do induction on B or C, just not true. So what you can prove by induction is the following stronger statement. Imagine A does not equal 0 as fixed, okay. Then prove for all B, if AB equals AC, then B equals C by induction on C. This gives us the extra flexibility we require. Note that we will be quantifying over all B. In the inductive hypothesis, it is essential that B is not fixed. Intro. equals C, successor of B equals C. Yeah, okay, I'm not too sure what this revert stuff means. Okay, let's try induction on C, because that's what this hint is telling us. I'll leave everything I've done so far. Induction C with 0. Sorry for now. Successor C prime inductive hypothesis. Induction. Okay, I should be saying that I can do this. Generalizing B. I should need a general. Okay. Ooh, interesting. Now we have an interesting set of hypotheses. We do have an inductive hypothesis now. That's a little different. Okay, so now we have A, C prime, B. Okay, and then we have HA, which is A does not equal 0. We have H, which thing we had before. A times B equals A times successor of C prime. We have our goal, B equals successor of C prime. And we have our inductive hypothesis, which is different than before, which says for all B belonging to N, for all natural numbers B, A times B equals A times C prime implies B equals C prime. Maybe then for our hypothesis we're going to use like B being like we're going to pass in the value of successor of B. Let F equal A times successor of B. Successor of B equals C. Oh, we don't want successor of B prime here, I think. Okay, we should do the inductive hypothesis of B. We have B equals C prime. We kind of want to have like predecessor of B or something in this case. How's your pass in C prime? Let's just trivially. Okay, we need to use our inductive hypothesis somehow, and we'll figure out how to use it. Our hypothesis is A times B equals A times successor of B. We need to use that somehow. A times B equals A times successor of B. Here we have A times C prime. Do we do induction again, maybe? I'm not sure. Maybe we need to do induction on B now, because B is a variable that can be whatever. Let me think about this a little bit more, and I might switch to also trying out an induction on B as well. Okay, so for any B that we pass in, A times B prime, B times C. Yeah, kind of like wish we had a successor on C, not a successor around B. Okay, let's try to do induction on B, because that'll get a successor around B. Okay, with 0, I'll go to sorry for now. Successor B prime, induction hypothesis prime. Okay, what does this get us? Whew. Now our goal is successor of B prime equals successor of C prime. Okay, and then what happens if we let F be defined to be IH of B prime? B prime equals C prime. That looks promising. And B prime equals C prime is true. Okay, okay. I think I might be getting somewhere. Okay, we've used our next hypothesis, not prime version, to get F. Oh, but now we have F and IH. Maybe IH is useless. IH prime, I mean. So let's ignore IH prime. I think we can massage H to get. Yeah. So let's rewrite mole successor at H. Let's do it twice. Okay, let F prime equals add, right, cancel 1, 2, 3 H. Okay, what should this be? This should be add left cancel. Not right cancel. Add left cancel. Okay. F prime. Nice. We can let F double prime be defined F of F prime. F double prime is B equals C prime. Oh, nice. Okay. We're so close. Yeah. So just apply F double prime. Or does it apply, or just rewrite F double prime? Reflexive. Woo! We solved the successor case by doing induction twice. Boy, was that tricky. Now we gotta solve our sorries. So the first sorry, B equals 0. So let's do mole 0. we write add h. So we need b equals 0 because of our proof. We can solve this. A times b equals 0. Go to our advanced, or just scroll up. Mul positive maybe. Nice. Okay, we just use this. Let f be defined to this. This takes something h. Exact or dot elim f. Okay. Function a0 2. Sorry. Function b0 2. Sorry. Okay, so we know that this means a equals 0 or b equals 0. ha dot elim a0. False dot elim. Okay, that takes care of that case. Now exact b0. Just b0. Oops. b0. I guess here we just put the identity function, right? ID. Yes, the identity function. This is the identity function. This takes care of that case. And we finished our first sorry, and that was kind of an involved base case. Okay, let's do our second sorry. 0 equals successor of C prime. Okay, well, we can solve this, I think, the exact same way. I'm just going to copy this whole chunk of code over and see where it takes us. Oh, does that just work? I don't even do anything different? Okay. Great. And that's, after a lot of work, that was hard, mul left cancel is solved with a very long proof. I think it's going to be one of my longest proofs yet. Let's see, how many lines is that? This goes from line 57 to line 85, nearly a 30-line proof. Let's zoom out so we can see it in all its glory. Oh, wait, no, we have a right squiggly line here. Uh-oh. Let's zoom back in and fix that. That is not quite right. Okay, let's mul 0. Okay, h is this. Does mul 0 do anything? Okay, can I do h dot sim? Dot symmetric. Then okay, yeah, that makes sense. This will be ID. Okay, what is f now? This is okay, f, okay. A equals 0 or successor of C prime equals 0. Or dot elimination f. In this case, what is this? A equals 0. Successor C prime 0. This is that, and then this is just What is this? Sorry. Let's put a sorry here for now. Is it not just this? Oh, .sim. Okay. In that case, this can just be eq.symmetric, right? Heck yeah. And we don't even use the inductive hypothesis here? Oh yeah, that makes sense. Move the E like this. Oh, we do need F. Oh, so we do use it. Huh? What is this F? Why is it saying this is unused? It's not used here? Is this a different F? Oh, it's a different F. Let me call this, wait, no, what? It's a bit confusing. Okay, well, if I do this, oh, that makes sense, but why is this F unused? Now is this working? Let's look. If I go down here, I put my mouse down here, unused variable wealth, that's fine. No goals. That's great. Guess I can just move this here and comment you out. Get rid of that unused variable shenanigan. I guess I can just call you F prime, F prime. Let me go back and give some. Should I get better variable names? Nah, that's fine. There you have it. Mole left cancel, zoom out in all its glory. Oops. Don't want that. Well, thank you so much for joining me and watching me tackle this tricky math proof. Watching me struggle and then get there in the end. I hope you had fun. I sure had a lot of fun solving this. And next time we'll be doing our very last world, the inequality, or the either inequality or advanced inequality world. What's it called? Oh, just the inequality world. Yeah, well, thanks again for watching, and tune in next time. Leave a comment if you learned something or you enjoyed. Bye.